Welcome to the Cloud Mentorship Program. This is the eighth session, and we are going to assess and discuss an important topic. And I've got a lot of feedback and requests to specifically talk about this topic, which is the edge and the relation and the integration with the concept of telco cloud. I hope that this session will be like a foundation for you that whenever you're going to assess or to experience any interaction or any reading about the edge, this I think will ease and organize the way you interpret whatever you are getting as I said, in terms of slides, articles, press releases, technical stuff. So I hope this will be a good foundation, and I try to tailor the content to be more like touching the telco stuff and to be more telco oriented. Let's start, and the initial starting point for us professionals coming from telco is just to recap or to understand the various segments or the various domains of the mobile network in general. So usually we have the access, or some we can call it the RAN, or you can call it whatever naming the operator is using. But the access is usually the node Bs, the E node Bs, and the 5G, the G node Bs, and whatever consolidating that kind of radio interface like the RNC. I excluded for sure the 2G because it's too old. So usually that domain, the access, it covered the RNC, the node Bs, and the E node Bs and G node Bs. And you have the core network, and usually the core network classically it is like a CS circuit switched, which is the old core providing voice services, and the PS core or packet switched or data core, the one that's providing the data service. I'm bringing here the 4G core just for simplification. You can also add the 5G core, but here I'm talking about the 4G core. So we're talking about the MME and S gateway and P gateway, and SGSN is the 3G core node for the packet core in the 3G. So you have usually two main domains in the mobile network, the access and the core. And usually the connectivity between these two domains, the intra connectivity inside one domain, usually it takes the level of transport network, sometimes transmission when you're talking about the access part, integrating with the core, aggregating the access. So you get this kind of terms that usually form departments and teams with the name transport, network, and transmission. Most of the colleagues here, or the colleagues here, for example, the group from Telecom Egypt, they are working on the access. The group from Jawal, for instance, they're working on the core. Me personally, I worked in the integration, the network part, integrating the access with the core, and also I worked with Nokia and Huawei in the core and the STC. So most of the telco professionals, we work in the network side. I mean, in working on the network side, we work on these domains. There are other domains that you may find in the operator, like the VAS, the value added service. I think Rama Khatib here from Syria, she's working in the VAS. That's the value added service you can provide on top of the mobile connectivity. That is the classic service that mobile provides. And there are the OSS and the BSS doing this kind of service provisioning, service assurance, and the BSS doing the billing and revenue and this kind of customer handling. So there are a lot of domains, but from network perspective, they are usually classified or segmented into the RAN and the core. The services that you are providing, usually, classically, it's all about connectivity, that you are giving connectivity either to the consumer, the end user like me and you, or to the enterprise, like to the companies, small, medium enterprises, factories, whatever, or a wholesale, which we call it B2B2C, like you sell to someone who, on your behalf or by his identity, sells to the consumers or the enterprise. This is like the classic legacy mobile network and mobile services. As you may interpret, the slide title is called Road to Edge. And this is important for us as a professionals to understand why would we go to the edge and what is actually the definition of the edge. Okay, so that's why I started with the classic legacy mobile network, and now I'm going to explain how I would say from architectural perspective and from service perspective, how we used to provide the service. And I'm using the past tense in the verb used because I'm talking about the 4G, and most the operators like in the Gulf, in the USA and Europe, they are on 5G, NSA in particular. So I'm focusing on the 4G. I know some operators haven't provided the 4G yet. For example, we knew that from Al Jawal team, but we're taking the 4G at the moment. So from latency perspective, or let's say the services provided by the 4G network, usually it required like some sort of end-to-end latency from 20 to 50 milliseconds. These numbers are not accurate because there is no one place that does this kind of benchmarking, but I tried to scan multiple references and multiple documentation from the vendors. For example, some vendors say in 4G, the air latency, I mean the latency from the terminal to the eNode B end-to-end is about 10 milliseconds. Some references coming from the ITU, which is the IMT document that provides the 4G requirements, and other documentation from other vendors. And based on my experience, most of the 4G services to be functional, it needs like 20 to 50 milliseconds. And based on that, services like internet, like the old MMS, like even the streaming regarding its HD or FHD, somehow it is fulfilled by the 4G latency. And with the classic 4G structure, you had the core network, which is, I have the green and the orange color. The green referred to the all the nodes doing control plane processing, like signaling transaction, like SGSN and these kind of things. And the orange ones are the user plane processing. So the green ones like SGSN in 3G and MME in 4G. And the orange ones are the user plane processing nodes like the P gateway, for instance, in the 4G and formerly the GGSN in 3G. So with these classic services and with this kind of structure or architecture, we were able to provide the 4G services, or let's say we were able to fulfill the 4G promise. Okay, we didn't have to do any kind of dramatic change in the architecture to fulfill or to fit to a certain service or certain product requirement, because most of our services or all our services, either it is to the consumer or to the enterprise or to the wholesale, were fulfilled with this kind of classic architecture. Starting from release 14, 3GPP has releases. Okay, for instance, release 15 is the 5G release, release 8 or 8 is the 4G. So between the 8 and 15, in release 14, which was the last release between the 5G, a new feature was introduced by 3GPP called CUPS. And CUPS, as the name implies, it is the control plane and user plane separation of EPC node. And EPC, that's the evolved packet core. So they give the flexibility that you can split the core node into a control plane processing and user plane processing. For example, if you have a P gateway, which is the gateway in the 4G, you can have a P gateway C, which is the control plane, and a P gateway U, similar to S gateway C and S gateway U. So that was the split. And by that time, the split was there, but there was no explicit use case that you would take the user plane and you put it in different data centers. So most of the deployments by that time, even the pilots, was just about the splitting control plane and user plane from the same node, but they both reside in the same data center or the same site. There was no real request from the business, from the market, to have this kind of user plane placement in different data centers in the edge and any other data center. No, the split was only the thing. And by the way, by that time, there was no real adoption for the cups because most of the operators were seeing the 5G is coming. So they were eager to wait for the 5G and see how this kind of split will go with the 5G. And when the 5G was introduced, and I'm bringing here on the left the classic and the well-known 5G requirements figure that was there in the IMT 2030 2020 publication by the ITU, the International Telecommunications Union. And that showed the 5G requirements compared to 4G requirements or with respect to 4G requirements. So if you see this light green thing, which is the IMT advanced, that's the 4G requirements. And if you see that dark green, that's the IMT 2020, the 5G requirements. So if you, let me choose maybe one of the aspects here to give you the difference. So in the IMT advanced, if you see my cursor here, I'm talking about the latency. So in 4G, it was 10 milliseconds. In 5G, it should be 1 millisecond. And that's the ultra latency thing that you hear about the 5G. But then the basic question would arise here, is this the latency between the UE and the G node B, the air latency, or that's the end-to-end latency? Okay. So our perception and our understanding to that is that should be the end-to-end latency from the terminal to the service and service to the terminal. But practically, some documents and some vendors are talking about 1 millisecond on the air interface between the terminal and the access. But again, the interpretation, the way this diagram was showed, the way it was explained to the operators, it was about end-to-end latency from the terminal to the service. So now there is a challenge because the way our network was architectured to have this kind of access sites, so having the E-node Bs, and then you have the regional site, national site that have the core network, and then the service, okay, that lies on the internet or lies on any kind of local POP. With the 4G, it was 20 milliseconds to 50 milliseconds, so it was okay. But now if you need to go for a 1 millisecond from the terminal to the service, then no way you can have the user plane part of the core, like in the regional site or national site, away from the access site, and no way you are going to have your service lies somewhere in one of the providers or one of the service providers data centers. You need somehow to shorten the user plane mile to have it as close as possible from the terminal to have this kind of 1 millisecond thing. But to have 1 millisecond latency, this is not an objective. I mean, we will not spend millions to build the infrastructure near to the terminal, near to the end user, just for sake of realizing 1 millisecond. The condition here is to have the right business case or the right set of use cases that will bring revenue to the operator, and that will justify this kind of investment, because usually the infrastructure are there in the core, in the regional sites or the national sites or national DCs or regional DCs. If you plan to go to the access and build an infra and put servers and put computational power, this will cost a lot. Then there should be a justification. With the 5G and with the new use cases like that 5G suggested, whatever I'm going to explain now became somehow justified, that there are some set of use cases. I assume that there are some set of use cases related to autonomous cars, driverless cars, smart city, some SOS stuff, this kind of things that require that you get the user plane of the core, you take the service, and then you put everything in the edge or in the access or in the POP near to the terminal. Why? To fulfill the 1 millisecond or the ultra latency requirement. But the second why is more important, Why? To fulfill the business case that will bring revenue to the operator. But if you don't have the business case, if you don't have the use case, then you will not do that because it's a huge investment. And here I will just highlight something, and maybe we can take it in next sessions. Even the ORAN itself, I'm sure you heard about the ORAN, and you heard about this kind of infrastructure that is there to host the stack of the ORAN, CU and DU. The business case is not just it's not justified unless you have an edge business case. For example, you cannot just build an infrastructure to host the RAN stack. This is not a justified business case. You need something that will bring revenue to you. For example, a use case that for a certain vertical, for the mining, for whatever, to justify investing and spending a lot on the edge. Because if we assume that national sites are 2, regional sites are 10, most probably the edge sites will be hundreds and thousands. Just imagine that every group of eNode Bs are tied to one edge data center. So you can get thousands of sites just to push the edge. So before the 5G, there was the rise of, or there was the standardization of the MEC. Formerly, it was the Mobile Edge Computing, and then ETSI, the European Telecommunication Standards Institute, they changed the name to Multi-Access Edge Computing. So they are the first ones to, from telco perspective, suggested to push the service into the edge with the goal of improving user experience. So the MEC, before the 5G, there was really no interest from the operators because there was no use case. But with the 5G, they started to embrace and test the concept. And most probably you will see that term MEC is often used. But MEC, again, that was the name of the working group. It was called Multi-Access Edge Computing. It has many standardization to outline how the telco edge DC would look like. And I have one slide today talking about MEC, HCMEC perspective and vision about the edge. I will stop here and I'll take your questions and then we will move forward. I have, okay, so the question is, how much I was asking about the ultra latency, the 1 millisecond by the ITU. Is it between the UE and RAN or UE and service? As I said, the way we interpreted that it should be between the UE and the service, but practically after working with the vendors and doing, initial assessments, 1 millisecond is more like the air interface between the UE and the RAN. Any questions so far? Please feel free just to maybe either you put it in the chat or maybe you can just ask the question. Okay.
Don't know where's my shoe. Maybe my shoes is dead.
Okay, the question is, what is the edge for us in telco? Yes, I'm going to cover that, Carlo, in the next 3 slides. The question for the previous MIT chart about latency and other parameters, I believe this is the theoretical targets. How about the practical one on ground? That's a good question because the ITU chart, usually the ITU is the entity that provides the requirements. And for 3GPP and the other entities like SBOs and vendors to fulfill the requirements. So ITU, yes, they put the requirements and it is theoretical until being delivered. About the practical ones on ground, you can scan the internet whenever there is a good number in terms of throughput or latency. There is a corresponding press release from the operator or from the vendor. But till now, because the 5G standalone deployments are not there, so we cannot tell exactly if this promise is fulfilled or not. Latency is not a general parameter anymore, so I need to specify the latency for every service. Yes. For example, if you are, as an operator, you are going to partner with a gaming provider, and that gaming provider told you for the users to have the optimum experience, for example, using the AR or VR, they need a 2 millisecond latency. Then you do your best to give him the 2 millisecond latency. And formerly, what we used to do as a mobile operator, we used to try to provide a specific quality of service, like guaranteed path or guaranteed bitrate path for that service, so that users can use this guaranteed pipeline to work on that service. But for example, if it has explicit latency requirement, maybe it's a good idea if it's bringing revenue to put that kind of service on the edge. Let's continue. Okay, so I always talk about that point, that this domain, either telco, telco cloud, whatever, it has a lot of buzzwords. Okay, so there are two families of terms. The standard terms, the one that we all know from 3GPP, like what is RAN, what is NFVI from HCNFV. So for example, if you ask me what is NFVI, I know that NFVI is the totality of hardware and software that construct the infrastructure that holds the VNFs. Why I know that? Because it is mentioned in the standards. Standards 3GPP, what is SGSN, what is P gateway, what is PDP context. These are the standard terms. But on the other side, there are community terms. Okay, and these community terms are used and enforced by the influencers, the vendors, professionals, and the operators. So some of these terms become like a global community terms, like all of us acknowledge that term definition is XYZ, and some are very proprietary to the vendor it is using. For example, you may read a press release and you find that a lot of cloud native stuff, cloud native. So it is defined the way the issuer of the press release think of, right? Maybe it's not the proper definition, but that's how he used the word. So the term edge is a community term because it has a lot of flavors. It's being used in many contexts, and you cannot have like one definition of edge. That's why I'm bringing most of the combinations in the next two slides, and I'm trying to define to you exactly what is a telco edge from my experience. But at the end, maybe another professional in another context takes another approach. But I'm telling you here what is most of the community is doing, what are the terms that we are using. So you can find a lot of X edge, like near edge, far edge, telco edge. So that's like a map to understand the terms. So you may have an edge or a definition of edge with respect to DC positioning. For example, like think of the core as the reference. So near edge is a data center near to the core. Far edge is very far from the core. Deep edge is like a deep far from the core. So you can get that edge terminology with respect to this DC positioning or the being close to the end user. So for example, when you say deep edge, then you have reached like the hop of the end user. Maybe when you say device edge, so that's the device of the user device. So that's a kind of terminology that we use when we describe the edge or being used in the community. Another type of naming is when you describe what kind of service that you, what kind of domain that you are serving, or what kind of families of business use case that you are trying to serve with that solution. And here you hear the term that of telco edge or enterprise edge, operator edge. So for example, enterprise edge, that's an edge solution tailored for the enterprise. Telco edge, that's, for example, one hop from the regional site, and I will show you that in the next slide. So you may get these kind of terms whenever you work in telco domain. You can get another family when you get terms that being used in the community or a market products, like products from the vendors. Uh, Edgebox, for instance, there is one solution from EAM or Salat with the name Edgebox. So that's the marketing term. AWS Wavelengths, that's the Edge solution by AWS. HC MEC, that's the name used by HC to describe the Edge specification. GSMA multi-operator edge. So GSMA as an entity, standardization entity, they are also have their own specifications for a multi-operator edge and more. So you have to be flexible enough to be used with that with these terms. And then you have the press releases that will have fancy wording to show you that there's a lot of innovation happening, a lot of progress, and this kind of thing. And my advice is when you read the press releases, do not try to take technical info out of it. Okay, press release is not the right place to get technical info. Just take the headlines. Okay, because usually the marketing terms are not really reflecting what's happening on the ground, and I have a lot of references for that. So, for example, you can get Telco Far Edge enabled by AWS wavelengths. So this is how it is written. This is how it is mentioned. Does this map to something real on the ground? Maybe yes, maybe no. So from edge perspective and from DC positioning, usually most of telco workloads, telco applications, they exist in either central DCs or the regional DCs. Okay, and I think we talked about that in second or first or second session. Usually, whenever you go one hop down in the downlink path, you go to the aggregation sites, like the one that hosts the OLTs, or maybe you go to cell sites. That's usually classically what we call the telco edge or the provider edge. And that maps somehow to the concept of near edge or far edge. And when you go like deeper, when you go to the enterprise itself, you always get the term UCPE, universal CPE, or you can also get the naming of the private 5G in the context of enterprise edge. So reposition private 5G at the enterprise edge. And when you go to the device level, you hear terms like IoT gateway and UCPE as well, and this kind of IoT terms. So from telco perspective, usually when you go one hop or two hops, that's the telco edge. But the question is, shall we go one hop? Shall we go two hops, three hops? So what determines that is the business use case. In the business use case. For instance, if you have like a huge fiber network and a great transmission network, and you can fulfill the latency of X millisecond while you are in the regional sites, then that's fine. No need to go further. If for a specific business case that's going to bring revenue and it has really a strong business plan, requires a certain milliseconds latency that's not fulfilled unless you go to the aggregation site. Then the aggregation is your edge. And that's why classically, when we do like any kind of edge deployment, we usually start by doing an end-to-end assessment for the latency across the nation to know exactly the latency across all the nation so that we can determine explicitly where are the locations of our edge POPs that are needed to provide this required latency for the business cases. So this is the definition of the edge. I will close this section with one definition that I like from Alex Resnick. He was the chairman of MEC by that time, 2018. He was trying to explain what is the edge. So from telco perspective, I will just read the definition. Edge is any location in your network where compute and related infrastructure, platform, software, etc., and services are offered closer to the user than your default data center cloud. So if your default data center cloud is on the regional and you started to go like closer to the user, one hop or two hops, that's the edge. That's the definition of the edge. Okay, so I will stop here and see if there are any questions. Any questions? Okay. I'm not sure if this is a good sign or bad sign, but are we all following? Maybe sum up if you are. Okay.
Excuse me, Karim. Just, I don't know if I get it right. So, when we're talking about it, for instance, we have a course sites, and you have users distributed in different areas. Does having an edge means, or mean that, for instance, you have some users, they have latency. Will you create a core site near these people? I mean, you would course sites. I want just to have a clearer idea in my mind.
Yes, exactly. For instance, let me give an example of Egypt, for example, as a nation. Okay. So you have the capital in the middle, which is Cairo. Okay. And you have like the north and south. So the internet routers or the internet exit for any service, internet service, you have to go through to the Cairo DC, the Cairo National DC, whatever the Cairo. So if you want to provide a certain service to Upper Egypt and South, okay, and that service require 2 milliseconds, for instance, then no way they can take this service from the Cairo data center. Then you need to build a data center in Upper Egypt. That data center will have the user plane functions, and it will have the service in the same data center. So you will have something called local breakout. So you go to the people in the Upper Egypt, will use the service in the Upper Egypt data center, and then they will not go to Cairo or to any internet router. No, the service will be provided from Upper Egypt, the data center. So yes, you are building basically an edge data center near to a certain geographic area. And that's why it's a lot of investment if you want to cover the whole nation, because you'll have to go in a very distributed manner and build thousands of sites. And you know what? These thousand sites, you have already an infrastructure, which is the tower, the radio tower. Radio towers are already scattered. So that's why whenever the operators are thinking of the edge, they couple that with the concept of O-RAN. They say that, okay, we are going to build the infrastructure for the O-RAN to cover the nation. So why don't also we put an infrastructure that would carry or that would onboard edge use cases?
Yes, thank you. You know, we have in when we launched 2G in the past in Jawal in Palestine, as we don't have the permissions, we do have data center, but it was for calls in London, and another one is still in Jordan. So we get rid of London site maybe a couple of years ago, and that causes us a lot of latency in some calls. So when we have the Jordan and the location in Ramallah, but of course Ramallah, because it's inside the West Bank, has more limitation on the equipment that we have. And currently we have another 2 sites inside Palestine, but in the occupied area. So we have the permission there to enter some equipment. So I think for us, then Ramallah should be our edge. And then the other sites will be, okay, Jerusalem also is considered an edge, but other sites could be a far end or something, or this.
Yeah, for sure. The current case of having the core data center in the UK or in the occupied Palestine, for sure this is not the right technical thing, but that's because of the occupation. But if you are going to provide a service for a specific, for example, let's say you have an industry vertical, for example, healthcare hospital in Ramallah, that will require a specific 5G edge use case from you as a Jawal. Think of it as if you are providing the hospital a managed Wi-Fi, but you are providing that on 5G. then most probably you can start to build like mini data center for that specific use case to serve Ramallah and to serve that customer. So usually who does that are the like radio planning guys. They see the nation and they tell you where are the towers should be there, and usually the edge data centers will follow the towers somehow. But that makes sense, Anwar, in nations with big land, big geography like the US, like Egypt. But usually, expect that in Palestine, for instance, if you have like the right DCs in the right locations, you can solve most of the use cases. You don't need to go that deep.
Yes, I think Ramallah, Jerusalem, and the other sites are, are okay. Jordan is a little bit far, but it's still near some of our locations. Thank you.
Thank you. Okay, so let's move forward, and now we go to I would say the edge data center ingredients. Okay, what usually you would have there. So as we agreed, like first point, that the idea itself of having on going to the edge is very coupled with 5G. There was no need to do that on the 4G. But in the 5G, you need to do that because of the ultra low latency requirements. And if you have a business case, or if you want to provide a network slice, which is another concept that we may explain in next sessions, you provide a network slice to a specific enterprise customer. You need to have, let me just add Fauzi here. Okay. If you reach second line, there's requirements for user local breakout. What is the term user plane local breakout? That the user plane mile in the mobile code should be terminated at the edge sites, because you don't want the user plane path to be extended to the core sites, to the internet, because that will prolong the latency, and you need to provide this kind of ultra latency. And that's why if you see here that the terms like, or the functional blocks, DU and CU, these are the logical or the functional blocks of the RAN or RAN and the RAN. UPF, that's the 5G user plane function, and whatever after UPF, that these are the services that are going to provide to the user. So I'm here drawing the user plane path, not the control plane. So usually, if the user is pursuing a certain service, for example, let's say that the user is enjoying a certain application that is based on virtual reality. So usually the uplink will be like that, will be from the UE to the antenna, RU, DU, CU, UPF, and then to the application. And then the downlink is from the application, UPF, CU, DU, RU, and then the terminal. So this is the uplink to the service, downlink to the UE. So as you saw, the service didn't exit the data center to other data centers. It what was locally terminated on the edge data center. So that's why you need to have all the value-added service, all the content data network, any GI LAN. The term GI LAN we usually use to describe any kind of service that exists on the GI network. And GI, that's the interface from the gateway to the internet. So usually these are the local application that is provided to the end user, like the DPI, analytics, value-added service, any kind of application, for example, V2X, vehicle to anything, autonomous cars, for instance, smart cities. All these are in the GI LAN of the mobile core. Usually on the edge data center, you need to provide three things: infrastructure as a service, which is the classic hypervisor stuff like the virtualization. The CaaS, container as a service, you need to have an engine or a platform to host containers. And then the PaaS, where you start to provide additional service to the CaaS, for example, monitoring, for example, automation, any kind of extra service that can be defined as PaaS from telco perspective. The edge data center is very coupled and the perfect fit for the vRAN, VDU, VCU. So whenever you hear the term O-RAN and you talk about the cloud solution to host the RAN components, VDU, VCU, the edge must come into picture. Okay, so now they are very two coupled topics. So these are the ingredients of the edge data center. And by the way, that was in a document that I worked on with the GSMA. So that's the reference architecture of the GSMA for the edge. If we go into more details, and I think maybe you have seen that before. So let's just zoom on the telco data center, sorry, in the edge data center. So let's say from what are the difference between the specs of the edge servers and edge hardware specification and the one that we use in the core on the regional side. So first of all, the form factor, the space itself matters. You know, in data center in the core, you have a huge spaces. You can put your chassis, your racks, and you put your stuff. But in the edge, most probably the footprint is very low or very small. So you have to use a special servers with special form factor. Form factor, that's the width of the server and the depth of the server. So the standard that we usually get, okay, and I'm not a server guy. So usually it's 1U, sometimes 2U. U is the unit of the one the one we use it to to scale the racks, like the height of the rack and the height of the server. For example, the rack is 42U. So 1U is the width of the server. The usual depth of the server is from 80 to 120 centimeters. So usually the server is something very deep and huge. In the edge, we see like usually sometimes half U, sometimes the depth is 30 to 40 centimeters. The surface itself of the server, it is manufactured to handle the rain, the heat, the pressure. So it is different, as the external body is different. So form factor in general, it is different from the core size. Accelerators, and you'll always see, and that term is coupled also with the edge. For example, Carlo brought one link in the chat from NVIDIA, so talks here is about the accelerators as well. You will find a lot of GPU stuff or FPGA stuff, like special types of accelerators for special types of servers that is there in this kind of servers, because they are to host special application. For instance, if they are going to host the DU and CU of the RAN, so this DU and CU and RAN, they are doing a lot of transcoding, a lot of signal stuff on the radio. So they need special type of accelerator. So most of the O-RAN vendors, they request that the servers hosting their application should have this kind of accelerators. And as I said, like something like the FPGA and the GPU. From security perspective, and people working on the mobile, they know that when you turn on a radio site and that eNode B start to register itself in the core itself need to authenticate and authorize that site or that tower or that eNode B. That we have to know exactly and guarantee that this node B belongs to us, because there are some security hack stuff that some scammers, they can simulate as if they are fake eNode B or the eNode B and get accepted by the core, and then try to steal the information of the subscribers. So in that sense, whenever you launch a new data center on the edge or a new O-RAN site, for instance, there should be a security measures to make sure that that server belongs to the operator. It's not a foreign server or intruder has put that server to get access. So we use some sort of many techniques, but the most well-known is something called TPM. It's the trusted platform module, something that it's a chip that you put on the server that actually authenticate somehow the server and make sure that that server belongs to us. The performance versus power, that in the edge, we don't have the luxury to have this kind of power consumption value that we used to have in the core sites. Okay, so we need a small server, small size server that actually give a very good performance with very low power. And in that domain, all the market players, they are competing, like Intel, Nvidia, that they can give you the highest performance with the lowest power. So from hardware perspective, the edge is somehow different, and these are the main aspects. From cloud offering, as I said, you need to provide solution for containers, to host container there, because most of the edge applications are containerized, and you need to provide paths like monitoring, load balancing as a service, and all these kinds of complementary service. The gray part, which is the infrastructure as a service, having a hypervisor that can carry virtual machines and also containers of virtual machines, because in the old generation, or the first generation of the ORAN, the DU and CU, they were virtualized based on virtual machines. That's why we had to provide a virtual machine solution that can host a virtual machine on the edge. But nowadays, most of the edge application, including the ORAN, the DU and the CU, are containerized. So the need for infrastructure service on the edge is not there. I mean, it's not there anymore. Unless there are, for sure, there are exceptions, but I'm talking about that trend. Software-defined networking, this means that you need to have the networking capabilities, either provided by the container platform, by external thing, but you need to have this kind of networking capability on the edge. From offerings, from service perspective, that edge solution will host the vRAN, for instance, the CU and DU. Will host the 5G core. That's why you always hear the 5G in a box, or the enterprise 5G that you provide. You give a box, a server, in vertical, to mining, to healthcare, to a specific enterprise customer, and when you turn that box, he gets a 5G in a box. It might look complicated how you can get a full 5G in a box, but again, think of it as managed Wi-Fi, as if you are offering managed Wi-Fi to a factory. Same thing. Okay, and at the end, 5G core, it's based on containers, based on microservices, and there is a mean by each vendor to instantiate the whole stack with ZTP, zero touch provisioning. Like you put the box, you turn the box, and then all the things gets installed automatically. What is very important, and that's from business perspective, that top right block, that you must have a marketplace that is open for your customer to start downloading application and getting more value of the edge. And that's the strength of the suppliers, of the hyperscalers like AWS and Microsoft and this kind of thing, because they tell you, okay, if you get our solution, we can go together, like with a joint go-to-market strategy. We can go, for example, and talk to the oil and gas sector. And guess what? For oil and gas sector, we have certified application in our marketplace. So your user, the oil and gas, can just go to the marketplace and start to activate product X and product Y. Similar for healthcare, similar for everything. And what makes it more, I would say, wider for innovation, that these suppliers like AWS, Azure, like Red Hat, since they all have a great community of developers around the globe, so you as an operator, you can open the space for a contest. For example, you can invite the developers and tell them, you know what, we are working on edge products. We are inviting you to develop a product that fits to whatever business use case. And if you win, we will adopt your application, we will give you money, and then me as an operator will win because I will get revenue from that application. And the rate of innovation now will be very higher compared to the old way of having my own marketing team thinking of a product that will benefit the market. Now I open the innovation to all developers. I personally experienced that when I joined with a team of professionals and developers from Egypt. We joined a contest by Verizon USA and AWS, and it was simple like that. We have an edge infrastructure, we have platform as a service. Come, if you have the AWS development skills, come develop an application for the edge, and if you win, you will get like a good reward, and then we will adopt the application we put in the marketplace. So we went there, and we thought about an application called near wild safety. Near wild safety, that you have a camera with 5G SIM card. It scans the camp if you are camping, and if it detects a wild animal, it sends a notification, an alarm, and that notification will go to the mobile operator, and that mobile operator will send an SMS to all campers or to all people in that cell ID that there is a wild animal, and we had like an artificial intelligence and analytics engine from AWS that can say that this is a bear, this is a lion, mountain lion, or whatever. So that information is going to be in the SMS. So you see, we thought about that and we made it. So edge will never flourish unless you have the right set of business use case, and that business use cases will not just come from one team in the operator working on a product, for months. No, you can just open the innovation, open that for the whole developers, for the students, for everyone. I hope that was clear, because it's an important aspect. And for sure, since you have a cloud stack, then you need to have controllers, you need to have the orchestration stack, you need to have the operational tools. I'll stop here also for some questions, and then I will finish with 2 slides. So please, if you have any questions. Okay. I will show you now let me get a question. Yeah, it's a good thing that new cells, it could be working on simple solar power. Yes, this might be one of the solutions to run the edge sites that you rely on solar, and that would work well, for instance, in Egypt, in the Gulf, in the Middle East, because basically we have a lot of sun. So yeah. Okay. So I'm now giving you an overview about HCMEC, what was their vision about the edge data center, and it's just informative. So you have an edge infrastructure. This is the hardware and the CAS and PAS layer, and then yes, that would host the DU and CU and the user plane, which is the 5G core, for instance. But they suggested something that was somehow adopted in another way by the ORAN architecture. They suggested that you may have something called mobile edge platform, okay, and that mobile edge platform would somehow integrate with all the edge applications, as you see the black ones. So you host your edge application, for example, the near wild safety that I'm talking about, and that mobile edge platform, as you see, it integrates with the CU and DU. These are the MEC service APIs. And think of it, why would a certain engine integrate with the radio stack and then integrate with the applications via APIs? Because simply the idea is I can get a lot of useful information from the radio about the congestion, about the users, about whatever radio stuff that I can get. And this kind of info makes a lot of sense and makes a lot of value to these applications. For example, the application for the V2X, okay, which require a specific latency, if he gets a feed from the CU and DU or from the RAN that the conditions are not there for this application to work, maybe I'll just raise an error that I cannot work because there is a congestion and the latency cannot be fulfilled. Okay. maybe when there is no congestion and conditions are clear, maybe the application of the virtual reality can now declare its readiness to do the required logic of the application. So the idea of having a brain or engine that can get input from the RAN and based on that can advise or suggest actions to the application was there in the MEC, and it is there also in the ORAN architecture. Okay, so this is just the edge host or the edge data center from the HCMEC perspective. My last slide, and that I would say matches a lot many of the vendors proposals for the edge. When I say vendors, I mean like Red Hat, Mirantis, Google, VMware, that you can have centralized clusters, like clusters that host application on the regional side, national side, code side. And you can also have many clusters that have control plane and user plane on the edge as well. And here the gray is the controllers, which is the control plane. And the black infrastructure, black server, these are the compute nodes or the worker nodes. These are the nodes that host the applications. So you find a lot of vendors have some sort of a collapsed solution that combine controller and user plane on the same server. Like one server can host control plane and user plane. So the idea of having control plane on the edge, it is there. But on the other side, there is also another approach that you can have only the control plane on the core sides. And then you can have distributed compute nodes or worker nodes only on the edge, so that you can have lower footprint on the edge and avail it only for the compute node or for the workers. Because imagine that you are on the edge and you have one server hosting edge application and another server it's not hosting anything, just hosting some control plane stuff. So this is a very high capex to be considered, because it's an investment at the end. If you invest a control plane at each edge DC, you may end up with 1,000 control node in 1,000 edge DC. And all these 1,000 nodes, they are not carrying applications. So it's a very high spending and high capex. That's why the DCN or the distributed compute node it comes into picture, that you can have the control plane centralized and then you can have remote worker nodes. Most probably when you go to the internet and start to see the solutions from suppliers, cloud providers like Red Hat, like VMware, Mirantis, and Canonical, these players, you'll find it most probably between these two architectures. Any questions? Okay, so that was the last slide. Let me stop the recording, but please do not go. Let me look.